Hello ICS3U. For May 1st to 5th, the first topic we'll be examining is trace tables. And trace tables, it's not coding, but it helps you become a better coder. What it does, it allows you to examine every variable as we step through the program. By now, you're probably noticing that you spend a little bit of time coding your project, and you spend quite a bit more time debugging your project, finding errors, tracking them down. The bigger your projects get and the more substantial they get, that becomes more and more true. In fact, a lot of professional coders will tell you that they spend about 75% of their time debugging their code, tracing things down and tracking down bugs and understanding why things work the way they do. They may not work the way that they want them to. So that's the topic of trace tables. There is going to be a handout that's posted there in Classroom for you to do after this. So I'm just going to switch to my desk here, and we're going to examine our first one here. So trace tables. I'll be going through about 4 or 5 examples here, and hopefully you can see that. I'm hoping it's in focus. Let me just pause for a second. I'll be right back. Okay, so that seems to be in focus. Here's our first example. So we start off by just taking a look at some code, and we're going to have 2 variables in this code, t equals 0, and we're going to have a for loop. Trace tables are really going to help you understand code a lot better, I think, and help you when you run into a problem. And it'll help you understand what you have to do to solve that problem. So that's the code that I'm going to start with. So you start with some code. The trace table will examine each variable in turn to understand what values it reaches throughout the execution. What I'll do is I'll start off with the variable t in one column and c in the other column. And I don't seem to have a ruler with me. That's fairly neat though. So we'll start off, t starts off at 0. Okay. And at that point, the for loop hasn't started yet. So I'm just going to put a dash there. And now we're going to start the for loop. So when we start the for loop, C starts at 1. C usually starts at 0, but in this case it starts at 1. You always want to identify, when you're doing a trace table, the independent variable, what I'll call the independent variable. That's the variable that doesn't depend on anything else. And in this case, both of them are independent of each other, but always identify the for loop variable if there is one. And you can pretty safely just write down all the values of the for loop variable because you know it's going to go kind of like a freight train. It's just going to go through and keep increasing its value by 1 each time. Now it does reach 5 momentarily just before it breaks, but it doesn't go through the body of the loop at that point. There's a print statement down here. You can ignore it. The trace table is designed to step through and show you the value of the variables as they go through. So t. So let's see what the value of t is at the bottom of the loop. We always look at what it is at the bottom of the loop after all the lines have been executed when c is equal to 1. So when c is equal to 1, this is the first time that we're seeing that this code is being executed, and t is going to be set to its current value plus 2. Its current value is 0. 0 plus 2 is 2. So we'll put down a 2 there. Then it prints it, the value of t and the value of c. It loops back around, sets c to 2, and t is now going to be equal to what it was before plus 2. It was 2. 2 plus 2 is 4. So looks like we're going to be adding 2 to t each time that we go through. And it's important to stop after we get to 4 at the end of the loop. It goes back around, c does become 5, and remember the way this works is when it reaches this, when the for loop reaches the value in the second parameter, it's like a while loop. So continue to loop while. This is kind of like while c is less than 5, less than that value. So this is just kind of in a bubble. And that's how you can read that second value. So it starts off at 1, but as long as C is less than 5, it'll continue to loop. As soon as it reaches 5, it stops. It doesn't execute the body of the loop. So you can stop there. Okay, example number 2. And that's it. That's it for the trace table. So trace tables are just meant to help us out with understanding what the values of the variables are at each point. Okay, here's my second one. So it's a for loop, only 2 lines of code this time. So for C in range, but this time we're going to be starting at 10 and stepping down. Remember the third parameter in the for loop, if it's optional, it is optional, but if it's there, it tells us how the for loop will be stepping. How's that look? Can you see it? Yeah, you can see it okay. Okay. And then the next line of code is D equals C times 2, stars times. So in this case, D depends on C. So we're going to start with the independent variable, C, and D as well. But C is the one that we really want to. We can put all the values of C down at the beginning because it's independent of anything else. D, on the other hand, it depends on C. But C is easy because C starts at 10 and it steps down by one each time, so it changes by -1. And while C is greater than 5, so as soon as it hits that endpoint 5, it exits. So we've got 9, 8, 7, 6, and when it gets to 5, it stops. Okay, D is always going to be C times 2. So, 20, 18, 16, 14, and 12. And that's it for number 2. All right. Number 3, we'll do another example. I've got 3 more examples for you. They're all kind of different and preparing you for the exercises that I have. Okay. For those of you that might be wondering, I'm using a piece of software called OBS. Open broadcast software. It's open source. It works with Windows, Mac, and Linux. I've got it on Windows system actually, and I'm using my phone as a second webcam so you can see my desktop here, and it's working really well. It's very easy to set up. If you ever wanted to get into webcasting, I'd highly recommend OBS. A lot of people on the web with channels are using it. And it's fairly easy to set up with a few online tutorials. Now, YouTube has a limit of 15 minutes. I'm already at 8. So I'm going to do my third example and see how much time I have left after that. I may have to use the second video just because I'm not being as fast as I should be. Here's the third example here. So while count is less than 10. So count starts at 0. Instead of a for loop, we've got a while loop now. Count equals count. Plus, so remember while loops, they're a bit different. In Python, we don't really use semicolons, do we? You might see that if you ever go on, if anyone's going on to doing any coding or computer science or computer programming, you may see semicolons at the end of lines. If you take the grade 12 course, we'll be doing Java, and you'll see that. You'll see semicolons a lot more. Now, so this is it for number 3. As you can see, there's only one variable called count. So we're only going to have one column, one row, or no, one column. So I'll just do that. So count very clearly starts at 0, and it continues to loop while count is less than 10. Every time the loop body executes, count is changed to be increased by 3. So we're going to add 3 to what it was before. Count equals 0 plus 3, so 3. Then it loops around. It checks to see if count is less than 10. Is 3 less than 10? Yes. So we can loop again, and that's going to be changed to 6. Is 6 less than 10? Yes. So it's going to loop back around and execute the loop body again. Count equals count plus 3, so now it's 9. You're probably noticing that there is some math here, obviously. There's a lot of counting principles involved in numeracy in its truest form in computer science. Okay, so now it's 9. It's going to loop back around. While count is less than 10, it's going to increase the value by 3. Is 9 less than 10? Yes. So it does go through again. 9 plus 3 is 12. So it does reach 12. Then it loops back around. It sees that 12 is not less than 10. So it can't loop again. So while count is less than 10, is 12 less than 10? No. So it ends. That's the end of the of number 3. So I'm going to stop here. I'm going to go on because I have 10 minutes. I'm only at 10-minute mark. So number 4, this one's a bit larger. I'm hoping to get this one done if I can. But this involves a list. And the list has 4 values. This is one of the ways of creating a list. And as you know, a list is composed of variables all of the same type. We've got another variable called count here. It's set to 0 for C in range. Excuse my chicken scratch. Hopefully you can read it. Okay, we've got list at location C. So remember, lists. So my list is called list. I could have called it anything, but I just chose to call it the name list. Lists and for loops, as we've seen in the classwork in the past little while, they go hand in hand. I think it's important that you really do the classwork that was posted before, at least the first 2 or 3. Just to get familiar with this before you, for those of you that are better with paper, you know, this is okay. So for our trace table, we're going to have what I would recommend you doing is for the list, every single location is going to be stated as a separate column. So I'm going to start off with my non-list variables. So I've got count, and I've got C, and then we have list. So I'm going to illustrate it like this. I'm just going to put list at the top, and then I'm going to put 0, 1, 2, and 3. Kind of like that. Can you see that? Yes. All right, so again, I don't have a ruler. My apologies. So at the beginning, what happens before the for loop? So there's 2 lines that happen before the for loop. We'll dedicate 1 row to what happens before the for loop, just for clarity's sake. C doesn't exist yet, so we're going to put a dash there. Count is 0. And list, every value in list at location 0 is 0. List at location 1 is 0. There's location 2. There's location 3. They're all 0. Now the for loop, we enter the for loop. C starts off at location 0. List at location C. So when the for loop starts, C is set to 0. So wherever you see C inside of the for loop body, you'll substitute the current value of C. Current value of C is 0. So we're going to be looking at list at location 0. And list at location 0 is going to be set to count minus 1. Now hold on a second here. Count, the value of count we have to use is the most recent value that it was changed to. The most recent value is changed to on this line. It's still 0. So 0 minus 1 is negative 1. Now count changes to count plus 2. So I'm going to do 0 plus 2 is 2. So the value of count actually gets changed after the value in the list gets changed, because of the order of these lines. Very important, the order of the lines, if they were to be reversed, that would change things drastically. Now, none of the other values get changed here in lists, so I'm just going to carry through what they are. None of these got changed. Okay, so now we loop back around. The value of C is now going to be 1. And I'm just going to keep my eye on the time here. I've got to stop. I'm going to continue this one in the next video because YouTube has a limit of 15 minutes for free users like myself. So I'll see you in the next video for number 3.